Hi everyone, it's Math with AUB. I have selected a tiny question of inverse trigonometric function, how to find its domain. How to find its domain. To deal with the domain, there are so many books thronged with the idea that domain is the input and range is the output. You are going to put some values and you are going to get a definite answer, then it is our domain and range to satisfy ourselves or a reader that is less familiar from mathematics, it is good for him. Like a parrot, he is going to cram and he answers that input, output, that is the case. But in reality, being pragmatic person, being practical person, how to deal with the questions that are asked to find domain. We have to take care of 2 to 3 things. Number one, denominator never vanishes. We do not accommodate the values where the denominator ceases to exist, where the denominator is overall zero. We cannot accommodate that values. We have to exclude. We have to wipe them out. They never ever belong to our domain. Number one. Number two, in square root, mostly we are dealing with real valued functions. Real valued function. If we are dealing with the real valued function, then we cannot accommodate any negative quantity in square root, because negative quantity in square root is an imaginary unit. However, in complex valued function, in complex analysis, where Cauchy's integral formula is the jewel of that complex analysis, it is affordable. You can manage negative sign in complex valued function. But in real valued function, we discard a negative sign in the square root. We can never accommodate the imaginary unit, complex numbers. Number three, for log are defined for positive values. Log are defined for positive values. Log are defined for positive values. These three things we have to consider in our mind, at the back of the mind, and these three things have been blended in a perfect manner and they are asked in a question of domain. Find the domain. You must be aware of that three facts, mindful of these three facts. Number one, denominator never zero. Denominator must be never zero. You cannot accommodate the values where the denominator ceases to exist. Number two, in square root, in case of real valued function, we cannot afford accommodate negative overall in square root because it is a complex quantity. And number third, log is defined for positive values. There are, however, bracket functions, ceiling or floor functions. They are good. They have less restrictions. Now let's deal with this question. Our question goes as f of x is equal to square root of sine inverse of 2x plus pi over 6. Sine inverse of 2x plus pi over 6. Look at this. There is no denominator. So there is no need to worry about the values where denominator ceases to exist because it has no denominator. Number two, it has no log. So don't worry about positive or negative values. Okay, there is square root. In square root, we cannot afford the negative quantity. So our first assumption is to be sine inverse of 2x plus pi over 6. It must be greater than or equal to 0. It must be greater than or equal to 0 because square root is present in numerator. So we can afford 0 as well. Here, solving for the values of x that gives us positive values in this case. Sine inverse of 2x, it is minus pi over 6. But we are familiar from the domain of the inverse function. Domain of the inverse function is here minus pi over 2. This is the domain or principal domain of this inverse function. Sine inverse x has principal domain as from negative 90 to positive 90, minus pi over 2 to positive pi over 2. We have to reconcile this restriction with this. This restriction with it is to start from minus pi upon 2. Here we have something minus pi over 6. So combining these two restrictions, we can write the inequality as minus pi over 6 less than or equal to, there is sine inverse 2x, what is sine inverse 2x less than or equal to pi over 2. Here upper bound or upper restriction, the greatest value is pi over 2. However, from minus pi over 6 to pi over 2, we are going to select minus pi over 6 because minus pi over 2 also lies somewhere after minus pi over 6. Means our interval length is in comparison to this one. To get rid of this sine inverse or arc sine, taking sine overall, we have sine inverse of pi over 6 less than or equal to here. Taking sine only. To get rid of sine inverse, taking sine. It will become sine times sine inverse 2x less than or equal to sine pi over 2. To get rid of arc sine, introduce sine. To get rid of sine inverse, introduce sine, and vice versa. There is minus pi over 6. Minus pi over 6. Minus pi over 30, from calculator one can reconcile that. It is equal to negative 1 over 2. Sine and sine inverse, they have been utilized. We have only 2x less than or equal to sine pi over 2. It is equal to 1. Sine 90 is equal to 1. Solve for x. Now we have domain dividing throughout by 2. We have minus 1 over 2 into 2 less than or equal to 2x divided by 2 less than or equal to 2. Solving for x, we have 2x dividing throughout by 2. We will get something like minus 1 over 4 less than or equal to 2x divided by 2 less than or equal to 1 over 2. Now we have the interval, we have the principal domain. Domain for this function is minus 1 over 4 less than or equal to x and x is less than or equal to 1 upon 2. Writing this in closed interval, big bracket means closed interval, minus 1 over 4 comma 1 over 2. It means minus 1 over 4 is included as well as 1 upon 2 is included. Every number from minus 1 upon 4 to 1 upon 2 is also included. We are familiar from the real analysis, from the mathematics. Between any two real numbers, there lies infinitely many real numbers. Between 1.1 and 1.2 lies infinitely many real numbers. It's dense, it is infinite. You cannot count the numbers from minus 1 upon 4 to 1 upon 2. Simply, the domain in that case is minus 1 over 4 to 1 over 2. From where comes or occurs this idea? In case of square root, we cannot afford the negative values. Look at the first restriction that we have taken. Whatever is inside the square root, we have taken greater than or equal to 0. Equal to 0 because of the fact that our function lies in the numerator. Function lies in the numerator. If there would have been a function like 1 over, then I would have taken sine inverse 2x plus pi over 6 is greater than or equal to 2. If this present in the denominator 1 over, if it is present in the denominator. If it is not present in the denominator, then we can afford 0 in the numerator. It is sine inverse minus sine inverse 2x plus pi over 6 greater than or equal to 2. It is a window for your thinking, thought. Please ponder over in that direction. If the same function is written in 1 over or whatever is something written in upon, we have to write this inequality as, we remove this portion. Sine inverse 2x plus pi over 6 is greater than 0. Because equal to 0 we cannot afford in the denominator. I hope you have started understanding how to find domain of a function in real time.